the
Yeah.
most common tool people use
Yeah. Yeah.
out of all
Absolutely.
HashiCorp tools. So
Yeah. Yeah. It was kind of a last minute thing. I'm like, yeah, I guess I'll do Terraform, and then it turns out to be my bestseller. So it's pretty awesome.
that's awesome.
Hi, folks. Thanks for joining in. Hope you are doing great and most importantly, staying safe. I'm Prabhas Sirivadana from WSO2, and this is our 35th Silicon Valley IA meetup. Today, we have Dan and Bryan to talk about HashiCorp Vault. They are the co-authors of this book, which was released last month, running HashiCorp Vault in production. In fact, this book is the one that triggered us to have this meetup. I've gone through it and almost finished reading. The content of the book 100% reflects the title. It's all about the best practices and guidelines run HashiCorp Vault in production. So if you are running HashiCorp Vault in production or intend to have a production deployment, you will surely find this book very useful. So with that, I'll hand it to Dan. Over to you.
Hey, everybody. Awesome to be here. My name is Dan McTeer, as Prabhat indicated. Just to give you a little background on myself, I've been working in technology for about 20 years now, just in various operational roles, mostly technical operations, everything from network engineering to system administration, things like that. Before joining HashiCorp, I worked at Adobe for about 4.5 years. 2.5 of those were spent running Vault at large scale at Adobe. And aside from that, my background's my educational background, at least, a little bit in security and things like that. So yeah, glad to be here. I'll let Bryan introduce himself real quick.
Yeah, thanks, Dan. Hey, everybody. Thanks for joining. Bryan Krausen. I'm a consultant, been working with AWS and HashiCorp for quite a long time. So working with AWS since, gosh, I think like 2011 or something like that, and before VPCs were a thing. And then been working with Vault for, I think, close to 4 years, maybe over 4 years now. So I do a lot of training on Vault and Terraform and things like that. My primary job is consulting for large enterprises around Terraform and deploying Vault and things like that. So definitely happy to be here. And yeah, I'll kick it over to Dan to go through the deck here. And
awesome. So I just wanted to kind of start real quick. I'm not sure how many people here watching this are familiar with Vault or any of the background or philosophy surrounding that. So I kind of want to cover that first, because without that critical context, it's difficult for the rest of it to make sense. So just real quick, back in 2019, just a couple months before I joined HashiCorp, I received an email from Marriott indicating that my rewards account had been updated. The information associated with it had been updated. I'm getting older. My memory isn't great, but I was pretty certain that that wasn't triggered by me. So as I dug into that, I was able to determine that my account was one of the ones that was compromised as part of their 2018 breach. My email address had been updated to point to some hacked website in Montenegro, things like that, and my rewards points had been completely dumped out of my account. So luckily, I was able to work with Marriott to get control of my account back, to recover all my rewards points, things like that. But are becoming very common these days, I would say, and kind of disrupting the lives of millions of people across the planet. So I just want to talk really quickly, touch on that 2018 breach. So during that breach, more than 500 million guest accounts were impacted. Stolen records included things like passports, contact details, credit card data, things like that. And as the details around that breach started to unfold, it was determined that access to their systems had been maintained for 4 years. And what happened was, at the time that they acquired the Starwood chain, those systems were already compromised and had been compromised. And once those systems were integrated into the rest of the Marriott infrastructure, those hackers now had a backdoor into the rest of Marriott, and that's how that That's how that information was siphoned off. So access was only discovered when a security analyst noticed that some privileged credentials for a database were being used to run some very abnormal queries against Marriott data. And as a result of that breach, over 28 million was spent just to clean up what was going on in their infrastructure. There was another $120 million, for instance, paid to the UK government for violation of privacy of their citizens and things like that as a fine. But luckily, lightning never strikes in the same place twice, right? So Marriott was hacked again the next year. This time it affected 90% fewer of the customers, but it was still a pretty significant number. Again, stolen records included passport information, contact deals, credit card data. The attackers in this instance gained access to Marriott's system through some credentials from a couple of employees in one of their franchise branches. The most shocking revelation, I would say, from all of this is that the keys used to encrypt credit card data were being stored with the credit card data. And so, even though that data was encrypted, it was completely a completely useless protection because access was sitting right there with it. So, so here are some numbers. I actually pulled this from the Verizon. The Verizon Data Breach Investigations Report. I'm not sure if anybody follows this. This is the most current one from 2020. It basically, they basically talk with thousands of large enterprises on, what the key points are of their concerns, how breaches usually happen, those sorts of things. And so pretty staggering numbers here. But I would say the most revealing of this data is that, number one, data breaches generally involve human error, stolen credentials, things like that. And number two is that in many cases, most of your employees are reusing passwords, particularly passwords they're using for, things like personal email and Instagram accounts even, right? So the interesting statistic that I don't have posted up here on this this particular slide is that 91% of people understand the risks of reusing their passwords, but only 60% of them, 60% of them will continue to reuse passwords anyways, right? Most people understand this is a dumb idea, but they just don't care in a lot of cases. So to kind of sum it up, static credentials are obviously killing us, but I feel like, the problem is a little bit larger than just that. So just to quickly discuss how that data relates to some of the common issues we face with regard to identity management. And I'm sure, many of these things are very familiar to the people in this group. It's common, for instance, at large enterprises to find use of things like service accounts that allow applications or services to access certain backend resources. These service accounts generally use a static username and a static password. The password's rarely ever rotated, even though it's supposed to be. And usually, people are hesitant to rotate those passwords a lot of the times because they feel like there will be production outages as a result or things like that. But in addition to that, we see a lot of cases where these service accounts, when they're no longer being used, aren't properly deprovisioned, and so they're just kind of sitting out there in space, waiting for somebody to take control of those, right? So. So we've had those problems in traditional static data centers, but we see that problem being exacerbated now. We moved from this very static, very defined situation to this new, very dynamic multi-cloud era. To some extent, it was simple to control credentials previously because they primarily resided in this very defined space, this very defined area. But the people that we support who are using these identity management services are increasingly finding ways to They accelerate their software deployment and those supporting operations, which means they're kind of going outside of those parameters because they can, right? We use things like Active Directory or LDAP, but now we have, IAM access to worry about in AWS and things like that. So during my time at Adobe, I would say across, AWS and Azure, there were thousands of cloud accounts sitting out there that were being used by employees. A lot of the times, employees that had no idea how to secure those accounts or control those accounts. And then within those accounts, you had access being provisioned to who knows who for whatever reason, right? And no process in place to kind of remove that access once it was no longer being used. And so automating access to these dynamic environments and ensuring there's a process in place to kind of clean that up once it's done being used is critical at this point to to making sure that we can sustain secure access to these resources kind of going forward. So ironically, there's a process that Marriott and many other hotels have used for decades in handling sensitive credentials, and it's proven to be extremely effective. It's known as the check-in and check-out process. I would argue that most are obviously familiar with this. You've probably checked into a hotel, checked out of a hotel before, but consider for a moment how that process can be applied to secrets management. So in the first step of the process, I arrive at the hotel, I walk up to the reception desk, there's a hotel clerk there to greet me. I state that I have a reservation, I make a claim regarding my identity. The clerk asked me to basically prove my claim, so I present that clerk with some credentials. In this case, it's probably a driver's license or a passport or something like that, issued by a trusted source. Once my credentials have been validated, my access is granted. There's two significant characteristics that exist with hotel access. The first characteristics is the access policy itself. There are varying levels of access at a hotel. Many are familiar with this. One person might arrive at the hotel for their very first stay. They don't really have any sort of access in addition to, just access to their room kind of a thing, or maybe a gym or something like that. When their credential is provisioned by the hotel, it just has that very limited access. Another person, they may be a frequent traveler. And so, they show up, they have this slew of perks attached to their identity, and that gets provisioned with their credential, right? It might give them access to a VIP lounge or something like that. And then we also have, this concept of the hotel manager, which probably has access to pretty much everything in the building, right? Based on their role there. So when a credential, in this case, a room key is provisioned, some type of policy is used to provision that key. A frequent traveler obviously, has some moderate level access, as we've talked about already, but kind of the second part of this, or the second characteristic that gets overlooked in secrets management is that time-based element. So regardless of what access that I'm given when I arrive at the hotel, that I know that at the end of my stay, that access is just going to be wiped out, right? I won't be able to go into my room anymore, the gym anymore, things like that. And there's some level of comfort there knowing that whoever stayed in my room before me doesn't have access anymore, right? Can you imagine showing up to a hotel and somebody provisioning your key card and you being told by the reception desk that anybody, just a heads up, but anybody who's been given access to your room in the last 90 days still has access to your room, so keep your door locked or whatever. Nobody would be okay with that, but for some reason we're okay with that when it comes to secrets management, to protecting our most sensitive pieces of data. So we talked about this already, but at the end of my stay, my credentials revoked. I know it won't be any good anymore at that point. My access to the hotel is complete, essentially. So So one of the questions I often get asked, and I've been in, many of your positions where I had to evaluate a secrets management tool for Adobe to protect digital marketing data that we were collecting on millions of people across the globe. So kind of to put it simply, to sum up Vaults, and we'll talk a little bit about this in detail in the following slides, but Vault takes kind of this tried and true principle of this hotel check-in process. It takes the tried and true principle of least privilege. Most people, I would argue, on this presentation are familiar with that principle and agree that that's a good secure practice. But it kind of adds two critical elements to that practice. And those elements are ephemerality and least duration. And so what I mean by ephemerality is Vault shines best, or it's meant to provision credentials that never are static. There's always some expiration associated with that. And then least duration, what I mean by that is when a user asks Vault, when a user authenticates with a Vault and asks for access to a credential, that access has a duration associated with it. And once that duration expires, that no longer, that access is no longer good. So ensuring users have, no more access than what they need is great, but it's really these two other elements that are, taking secrets management above and beyond. So Vault was really designed to be this identity broker, this hotel clerk, if you will. With Vault, a user essentially authenticates via some trusted identity provider, such as, Active Directory. If authentication is successful, the user is provided with a key card, or, in the Vault world, we call it a token. And that token has attached to it certain types of access based on security policies associated with that user. The best part about that token is that it expires, right? So after a certain configurable amount of time, their key card to essentially to Vault is no longer good. It can't be used to access secrets any longer. So I kind of covered this at a kind of a high level in the previous slide. Essentially, the way that Vault works is that you have policies written for users or groups or things like that. Those policies are associated with directory service groups, or Okta privileges, or things like that. Really, it can be a huge number of authentication methods that you can attach to Vault to suit whatever needs you have. And then those policies are associated with certain secrets paths inside of Vault. So this could be, a simple key value store. It could be access to provision credentials for a, some cloud platform. It could be access to credentials for Kubernetes or something like that, or access to Kubernetes, right? So you authenticate, your policy dictates what access you have. That policy is associated with that token. From that point forward, you're using that token to access whatever secrets you need. And then once that token expires, you're expected to re-authenticate essentially and get a new token. So kind of in addition to the flexibility as far as authentication methods, how you store secrets, things like that, Vault really provides a single interface for integration. This means that you can basically run Vault on any platform or cloud provider and offer a single consistent experience to your users. This means your support staff and users only have to be trained on it, one single tool. They only need to write one set of code for secrets management. This significantly reduces overhead and human error that are associated typically with security incidents. So while I was working at Adobe, kind of the way we handled this, right? So we were full multi-cloud and data center. So we were operating in Adobe data centers, we were operating in AWS, we were operating in Azure. And as probably everybody here knows, those three options offer three very different secrets management capabilities. Our goal here again was really to consolidate on a single tool to make sure that, you know, we didn't have to expand out training, which can be really expensive. We didn't have to expand out development time, which can be really expensive. And so we basically deployed Vault clusters across AWS, Azure, and Adobe Data Center using a network mesh we refer to as MCT, or multi-cloud transit. And all of those clusters were basically able to communicate with each other and replicate data back and forth. So all of our applications running globally were able to pick up secrets from upwards of 12 different places at any given time, to make sure they always got secrets and to make sure those secrets were always consistent no matter where they pulled them from. That experience was always consistent. I would say, though, that the biggest advantage here that we didn't fully realize or appreciate until after we started deploying, and we use this phrase often, but I really like how it's stated. We basically refer to Vault as being built by practitioners for practitioners. One of the great things is, and many of you know, if you've dealt with security tools, you know how difficult it can be to get people to adopt. Once word got out at Adobe that we were deploying Vault, we didn't have any problem finding people to onboard to the service. People were just showing up out of the woodwork, asking us if they could be onboarded to Vault and start using it for secrets management. And so, you know, typically you find secrets management tools designed by security engineers or things like that, people who definitely have a good mind for security practices, but haven't necessarily applied any of those practices in real world situations. And so that's kind of where Vault comes in. It has the security there, but it provides it in a way that, you know, especially DevOps groups prefer to use it. So on top of that, I just wanted to kind of talk about some of the integrations we have, and this is such a small list, I would say, but there are a lot of native integrations available in Vault at all layers, right? Lots of different pieces of the technology stack that we can integrate with, from authentications to secrets management, things like that. It doesn't really stop here, though. Definitely, you know, definitely take a look at some of our options that are available on the HashiCorp website. And you know, the great thing about this, though, is that I would say the underlying message here is Vault is so flexible, it can pretty much plug into anything. So even if you don't find something on our exhaustive list, there's good chances it can be integrated regardless. So, and then recently, Gartner released a report. They've created a new secrets management category, and we were immediately placed as #1 in that category. So I'm going to pause right here for questions. I don't know where those are coming in, Prabhat, or do we have those coming in on Zoom? Or
yeah, a couple of questions then.
Sure.
So you mentioned that the Vault functionality is exposed through APIs. Can you mention like which protocols are they, like just HTTP, or is it available through gRPC?
So it's full HTTP REST API. That's the only thing we support really right now. So all of our tools that are built into that. So you can use the Vault binary. The Vault binary is very lightweight, and so it's used to operate Vault as a service. It's used to also interact with that Vault service. So an end user can download the Vault binary and interact through a command line interface. But ultimately, that command line interface is interacting with that API. And same for graphical user interface. There is a graphical user interface as well, but that is, again, all plugged into that HTTPS REST API. So.
And you also mentioned that Vault has its own, like you can define your own policies.
Correct.
So in production, do you see like integrations with other policy engines, like with OPA, for example? Can you integrate OPA with Vault and define policies?
So HashiCorp does have and Brian, feel free to chime in on this too. HashiCorp does have a product called Sentinel that's also open source. You'll find that all all of our tools are open source first, right? Like we want to make sure people have access to great tools for free. So we do have a tool called Sentinel that is basically an OPA, our form of OPA. And so there is some integration there that really does let you kind of get fine grained. So, for instance, if you wanted to, make sure employee A only had access to secrets from 8 to 5 every day, you would employ Sentinel for something like that to limit the window of time throughout a day that they could access secrets, things like that. Anything you want to add there, Bryan? Or
yeah, I would just say, the policies within vaults, like you'll hear them called vault policies, ACL policies, just ACLs. You'll see them called a lot of different things, but they're all basically the same thing. And these ACLs or policy, I generally call them policies, but the policies are really Vault's RBAC solution, right? And so when you connect to Vault, you will authenticate with some auth method, right? Whether that's LDAP, whether that's a local username and password, a token, something like that. But then attached to the token that you ultimately get is the policy, right? And that policy provides you with that authorization within Vault. So what are you allowed to do once you're here, right? And back to kind of Dan's metaphor of the hotel, which you'll see in our book, is actually the very first chapter, I believe, very first paragraph, in fact. But if you take the metaphor there, so the authorization is Dan providing his license or passport, to prove who he is. But then he gets his key card, right? And that key card allows him to access, his room, but not my room, right? It allows him to access the gym. And if he's a preferred member, he can access the concierge lounge or whatever, right? So policies really provide this RBAC, role-based access control within Vault to say, hey, once you're here, what are you allowed to do within Vault? Can you go read this particular secret? Can you go generate dynamic secrets? Are you an admin level? Can you go and start enabling new auth methods or secret engines and things like that? So that's how I'd really describe, policies. And then to Dan's point, Sentinel is really, aimed to give you more fine-grained control beyond what policies can do themselves. Now, policies are pretty powerful. You can do a lot of stuff with them. But, once you start adding Sentinel, you can start pulling things in outside of vaults to evaluate with those policies themselves. So, are you coming from this specific IP address? Have you authenticated with MFA, things like that?
Yeah, so there's another question from Alan Cobb. Is it possible to delegate an authorization to someone else?
Yeah, so we actually have a concept known as control groups. So there's a couple different options, right? But that one in particular lets people request access, and you can grant it kind of on the fly. But there are ways, using vault policies and things like that to say, yeah, this person can have access right now. There's also a feature in Vault called Cubbyhole, where I can essentially store. They may not have access to my hotel room, right? But Cubbyhole is basically like a lockbox in the lobby where I can store a secret for somebody else and give them a key to open up that lockbox and pull that secret out, and use that kind of one time. And because again, the ephemerality, so I may like I may have an AWS environment that I want to give some other team 30 minutes to provision something inside of. And so I can basically say, hey, Vault, I need an AWS credential for this person to deploy something. And I can stick that in Cubbyhole and give that person the key to that Cubbyhole. Once they use that key and pull that credential out, there's nothing in the Cubbyhole anymore. But because that credential was only good for 30 minutes, they can use that credential to do whatever they were going to do in my AWS environment. And then 30 minutes later, that credential just disappears. It doesn't exist anymore, right? So lots of different options there to easily give access to somebody to some resource that they don't typically have access to. So
let's move forward. Yeah,
cool. Okay, so Vault architecture. let's look at some options for high availability, performance, things like that. So these are the diagrams taken straight from the HashiCorp website. Anybody can go and look at architectural guidance here. This is what a single vault cluster would typically look like. It usually consists of about 3 vault nodes and 5 to 6 console nodes, depending on where you're deploying it. Usually you would use 5 console nodes for on-prem, or 6 when you're going to deploy across availability zones in the cloud or things like that. Console has historically been the supported storage backend for a vault cluster, and I would say it's the most common storage backend in use right now, but there are certainly other options available if you want to use those. And we'll talk in a minute about kind of some updates to that storage backend. It's important to note, though, that Console and Vault use the Raft protocol to kind of handle leadership elections. And so because of that leadership election, there needs to be an odd number of members voting. And so you'll notice in this diagram that only 3 of the 6 nodes are designated as capable of voting. This is important when you're running an even number of console nodes. You would want to make sure there's an odd number designated to vote in the leadership election, so that you don't end up with kind of a stalemate there. So
the Vault server is like stateless, and the console will replicate the state between console instances?
Essentially, yeah. So, and not just that, but any persistent data that Vault is managing is being dumped into the console backend as well. So, anything you want to add to that, Bryan? Or
Yeah, absolutely. Yeah. So in this particular configuration, using console as a backend, Vault is absolutely, stateless. I would say the only thing that you may be writing locally, or maybe like audit logs or something like that, for a Vault server itself. But anything else, the configuration of Vault and all the data that's stored in like a KV store or things like that, they are written to console, right? So in this particular case, like in this diagram, if you had your console server running all the nodes in the pink at the top, and you were to wipe out the 3 Vault nodes, you could potentially just deploy 3 brand new Vault nodes, connect them to that same console cluster, and it's like nothing ever happened, right? So, so Vault is absolutely stateless. And as Dan mentioned, there are changes where there are other backends like new support, highly available, more enterprise back ends that have come out, I think in 1.4, that I've seen a lot more of recently. It's starting to become hit or miss, whether it's console or Raft, but yeah, so absolutely in this particular case, Vault is absolutely stateless.
Sure.
Cool. So this is kind of what a multi-region deployment would look like. In our case at Adobe, like I said, we had a multi-cloud, multi-region deployment. We had 4 major regions that we would cover. It was East Coast, West Coast, EMEA, and APAC, and each of those regions would have 3 Vault clusters in it, 1 in AWS, 1 in Azure, 1 in Adobe Data Center. And those were basically all interconnected with a feature that we refer to as performance replication. They were essentially replicating kind of user configuration, user access data, and in some cases secrets data across those. And so performance replication is essentially kind of an active-active configuration. Any one of those Vault clusters can be accessed at any given time by any application. But it is limited in what it's replicating. It is replicating things like policies and configured authentication methods, things like that. When it comes to actual secret data, only some pieces of that are being replicated, except for in the case of, and we'll get into this later, there's a secrets engine called the KV secrets engine. That data is mostly static and is being replicated out. But there are ways to control that for various compliance regulations in various countries and things like that. So
at that point,
yeah.
you encrypt the data. So I guess all the data stored in the this Consul cluster is encrypted. At which point you do that? Is done at the vault or when the data reaches the Consul?
So Vault is basically, I can't remember. They refer to it as basically a cryptographic barrier. So as it passes into Vault, not only are you using HTTPS to communicate with Vault, but as the data passes through Vault into console, it's being encrypted by Vault's master key, essentially. So when you provision a Vault cluster, that master key gets created. By default, it will you can break it apart into shards using a algorithm called Shamir secret sharing, and you can define how many shards you want to break the master key up into, and how many of those shards need to be brought back together to kind of reassemble that. So Vault, there's certain situations where Vault will go into a sealed state, like if a Vault server reboots. For some random reason, it will come back online, but it will be in a sealed state until the time you bring n number of those keys together and unseal Vault, and then it can start operations again. So lots of protections there for lots of different situations, but that data is being encrypted through the whole process, front to back. So.
And can we use something other than Consul, let's say a database as a backend server?
Yeah, so I do know of companies who use, AWS Aurora, for instance, or things like that. Officially, that's not supported by HashiCorp, but that doesn't mean they won't help you. Really, what it means is, if there's a Vault issue that's going on, they're going to help you troubleshoot that and get to the bottom of what's causing that. But if it's determined it was a problem with AWS Aurora, for instance, their hands are kind of tied, right? Like they can't go any further than that because they don't have access, they don't have the expertise necessarily, things like that. And so, yes, you can absolutely use some other type of database for that storage backend, but it's kind of at your own risk, kind of a thing. So,
yeah,
I would add that you probably lose some of the replication functionality along with that, right, Brian? Or
I don't know if. Yeah, I mean, so the first thing is, yeah, there's I think there's, I don't know, like 20 or 30 like different backends that you can use for Vault, right? You DynamoDB, S3 file. I mean, there's tons of stuff you can use. Now, only about half of them support high availability. So you can, to create a local cluster, right? So multiple nodes accessing the same backend to create a local cluster. But yeah, I think only, from an enterprise standpoint, right? If you're gonna deploy this in an enterprise and be supported by HashiCorp, there's really only two backends that are A, provide high availability, and B, are supported by HashiCorp technical support, right? So if you're deploying Vault Enterprise, you want it to be deploying either console as a backend or use the newer Raft, what's called integrated storage, as your backend, right? So those are really the two that you would want to use if you're, really in production and running enterprise. Now, if you're running like open source, right, you would, want to use something that supports high availability. It's up to you. If you're an Azure shop, use something in Azure. If you're an AWS shop, use something in AWS. So, use a technology that you're familiar with.
Yeah,
absolutely.
There's a question from Rohit Pansal. What is the authentication between Vault and Consul?
Yeah, so console, you should. A lot of people don't. I was just working with a company last week that they had something in production for a couple of weeks, and they hadn't yet enabled console ACLs. So when you deploy a console cluster, you should enable ACLs. And basically what happens is you create policies within console, and then you create tokens that are associated with those policies, and you give those tokens to Vault, right? So and then you want to make sure that your ACL configuration in console is set to deny, right? So unless you have a token, you can't talk to me, right? You can't talk to console. And so it's basically a token, an ACL token that gives Vault access to console, assuming it's locked down. If it's not locked down, then anybody can talk to console, right? So there's really just, there's no authentication requirements if you don't have ACLs enabled and configured correctly.
The great news, though, is that, again, it's associated with a key that you have to provide to Vault. And so just because you have access to console doesn't necessarily mean you have access to the Vault data.
Exactly. Yeah.
So.
Yeah, another question. Dan, you mentioned that when you store data in console, those are encrypted by master key. So is it a single master key, or can we define different master keys by paths or like that for data encryption?
So yeah, there's a lot of different options here, and it depends on how you. It depends a lot on how you first initialize Vault, and Bryan, definitely correct me if I'm wrong on this. So I talked about Shamir's key sharing already. That was the initial option, right? And so when you initialize a Vault cluster, again, you can say, you know, I want the master key to be split up into 10 shares, and 6 of those have to be provided when I unseal Vault and it's up and running, right? And so there's that option where you're taking a key and splitting it up into, you know, n number of shares. But one of the more common options nowadays is to use a service like AWS KMS, for instance, for what we refer to as auto unseal. And so when you initialize a Vault cluster using an HSM in the cloud, when that cluster initializes, it's dumping a single key into that HSM. Just for simplicity, right? The idea is that the HSM is protected, access to the HSM is protected, all that sort of thing. And generally speaking, nobody but Vault needs to talk to that HSM to get that key to unseal itself. And so really there is one key that gets generated. It just depends on the method you use to generate that, as far as whether it gets split up into shares or just sticks with one key, if that makes sense. So
yeah, I'll add on to that real quick. If you take a step back even a little bit further, closer to the data, when Vault is first initialized, an encryption key is created, right? And that encryption key is used to encrypt all the data on the back end, regardless if we're using console or integrated storage or DynamoDB or whatever. Now, in order to protect that master key, in order to protect the encryption key, right, that's used to encrypt the data, there's a master key, right? And that master key encrypts the encryption key. And the encryption key is actually stored alongside the data, but it's in encrypted fashion, right? And so the master key allows Vault to decrypt that encryption key and, you know, write or read data from the back end. Now, what Dan is talking about, the concept of unsealing and sealing, is you know, when a Vault node starts up, it is sealed, and it doesn't necessarily, it doesn't know the master key, right? Because that master key is not actually stored anywhere. In order to break that up, and in order to keep, you know, one single person from having kind of the keys to the kingdom, if you will, you can either split that up using the Shamir secret sharing algorithm. So you create the shards and you issue those shards out to different folks within your organization. So again, no single person can actually recreate the master key, which can in turn decrypt the encryption key, which can in turn decrypt the data. The other option, the downside, the plus side of that is it's super easy, right? It doesn't require the integration to, you know, outside services. You know, it's free. It works in open source, works in enterprise. What people are moving to now is auto unseal, and that's what Dan was saying. That's also kind of employing the use of Amazon KMS or Azure Key Vault or something like that. You create a key in KMS or create a key in Google or Azure or whatever. And what happens is Vault actually stores the master key in encrypted fashion, but it has to use the KMS key or Google key or Azure key or whatever, you know, in that KMS service in order to decrypt that master key, right? The plus side to that is that as soon as the Vault service starts up, it can immediately unseal itself and it's ready to rock, right? The Shamir sharing algorithm requires a manual intervention. So you have to have a threshold of, you know, different folks that can provide their unseal key in order for Vault to be able to reconstruct that master key in order to decrypt the encryption key in order to read the data.
Well, and just to be clear, when Vault goes into a sealed state, it is inaccessible. It's meant to be that way. And so when you use that old method of Shamir's secret sharing, you may basically be in a situation where you're having a production outage because Vault is sealed, right? And so time is of the essence. And so, having a situation where multiple people need to come together to reform that master key can sometimes mean the difference between 3 nines and 4 nines, right?
Yep.
So
yeah, just think about having to do that at 3 a.m. if you're doing maintenance or whatever. Now you're going to require 3 of 5 people or 5 of 10 people or whatever to get up in the middle of the night, provide their key to unseal Vault, and then move on. Right? It's not necessarily ideal.
yeah. So
Yeah, the last question, Rohit Pansal, does Vault support rotation of master key and re-encryption of the concealed data?
Yep. Yeah, so you can rotate the key, and that'll rotate the encryption key, right? The backend encryption key. Vault will store all versions of the encryption key in a keychain, and so older versions, data that was encrypted with older versions of the encryption key can still be decrypted. Newer data will be encrypted with the new key, and then yes, you can also rekey those, like we were talking about the Shamir sharing algorithm, right? It splits the keys up into key shards. You can rekey those. So, if Dan and I, were, working at Adobe and like one of us left and, I had one of the keys and Dan had one of the keys and we both left, right? Adobe's going to want to rekey that Vault. And so now our keys, aren't valid against their Vault. And now they can provide the keys to 5 new people. Right. So you can definitely rekey either the recovery keys or the unseal keys.
And there were a couple situations at Adobe where we did have to go through that process for various reasons. And it was like I can't even state how simple it was.
Yeah.
Like a couple of minutes kind of a process. So
yep.
Very, very simple to do. Yep.
Yeah, thanks. Let's move forward. Yeah.
Cool. So just real quick, I want to touch on disaster recovery replication. We talked about performance replication. It's kind of a limited set of data, but it's active. The disaster recovery replication, the DR vaults that you see here on the diagram, are a full kind of bit for bit copy of everything going on the attached primary cluster, but they are not active. They're kind of a warm standby. And there's a process that you go through there to fail over to those in the event of an incident. One thing I want to call out real quick though, one of the most appealing parts about Vault, at least for me from an operator perspective, was that we got to the point where using Jenkins and Terraform templates, we could deploy a Vault cluster in a matter of minutes anywhere on the planet, right? And so this really is built around automation, around DevOps from the ground up, right? And so that was really key. There were a lot of times where business would come to us and say, "Hey, we need a Vault cluster in India by tomorrow, or China, or wherever have you," and we would be able to meet those needs pretty easily because of all the functionality built around Vault and its ability to be part of automation pipelines. So cool. So we've kind of already touched on this. Bryan referred to it as Raft. It is referred to commonly as Raft. In some cases, it's also referred to as integrated storage. But this is a new feature as of Vault 1.4, I believe, that allows you to basically remove any storage backend from Vault. So Vault has its own self-containing storage backend. This was super appealing to me because, again, as an operator, the last thing I want to do is, run a service where I have to be an expert on some other service as well, just to make this primary service run. And so this kind of removes the need for you to be familiar with console in addition to Vault, just to get a Vault cluster to run, right? So huge benefit here to the operator. And in addition to that, I would say that a typical Vault cluster would be anywhere from 8 to 9 servers, right? And so this reduces the footprint of a cluster by 30 to 40%, which is a significant reduction in operational expenses and things like that. So cool. So let's talk about use cases real quick. The most common reason that Vault is used, obviously, is for secrets management. I know saying secrets management seems small and simple, but there's actually a huge number of options that can be leveraged here. Going back to what we discussed earlier, the intention of Vault is really to be an identity broker or a secrets broker. It's sort of like a DHCP server for identities, if you will, right? It manages leases for identities and then deletes those identities once their time is expired. So it solves kind of those three major issues we talked about at the beginning, as far as static accounts, password rotation, and account deprovisioning, rather than going through the tedious process of managing access to all of your technologies individually, inevitably creating sprawl. Vault can do a lot to ensure those things are being managed for you and according to your own specifications. So just as an example of that, let's kind of go back to the AWS secrets engine. Basically how it works is you configure that secrets engine with root credentials for IAM access, essentially, to an AWS account. And what happens is when you build a policy for a user to have credentials to that AWS account, what's happening is that user is authenticating to Vault. It's saying, hey, Vault, I need credentials for this AWS account to provision something, and I need them for 30 minutes. And what Vault is doing is it's using its root credentials to log into that AWS account and create a completely random username and password for an identity. And then it's spitting that information back to the Vault user, requesting that. And that Vault user is then free to take those credentials and do whatever they need to do for the next 30 minutes. And then 30 minutes later, Vault is going back into that AWS account and saying, hey, delete this account now. It's not needed anymore, right? So again, this is the huge power of Vault. This is the biggest part of why you would want to use it. And this methodology is applied to many of the secrets engines that you see within Vault. And so it really does, because it's doing this for so many different platforms, so many different providers, it really does make it that single medium, for all of those requests to be processed through, no matter where you need a secret from, really reducing that kind of area where you need to, interact with something as critical as identities. So here are the kind of the three major secrets engines. We've already kind of discussed the cloud secrets engine a little bit in the previous slide, but again, a lot of it works kind of generally in the same way for other cloud providers as well. We do support Azure, Ali Cloud, GCP, all those sorts of things. I want to touch real quick on the KV secrets engine. This is probably one of the most commonly used across all Vault deployments. I'd like to call this the gateway secrets engine. This is usually where people start, right, when they first adopt Vault, because it provides them a simple way to migrate their secrets from some place into Vault, to at least get them a little bit secure. In a lot of cases, it's people moving secrets out of code, for instance, out of Git, right? And they just need some place to store them. In other cases, it's, they're getting rid of their old secrets management tool and need a place to migrate those secrets to initially before they start the process of using, dynamic secrets later on down the road. So it's a really good introduction to interacting with Vault. Because the KV secrets engine is static in nature, we obviously recognize the downsides of using it and don't necessarily recommend it for long-term use. But I will say it's worth mentioning that, number one, the credentials, again, used to access secrets are ephemeral. So if I log in to Vault, Vault's going to give me back a token, and that token's good for, X number of minutes or something like that. It's that token that I have to use to actually access the secret. So I know that if I, copy paste that token, or if it's sitting in a command prompt or something like that, and then I go home and then, my dumb friend sees my laptop and sees that token, chances are good that token's not good anymore. And the person would have to re-authenticate to get a new token and to access that secret. So that's really the first value there. The second one is that there's a lot of flexibility that comes with the Vault API, particularly in secret versioning. So it's really simple to manage programmatic rotation of those secrets without kind of like munging any of the data or things like that. So one common use case for companies is to employ kind of like a blue-green password rotation. So for instance, if I have a secret stored in KV and I decide it's time to rotate that secret, I'll create a new secret value, and that will be version 2 of that secret value. What that allows me to do is go into my application code and say, try using the latest version. And if that version doesn't work to access this backend resource, then try using the previous version. This makes it very seamless when it comes to password rotation, because it allows you to kind of fall back on previous versions of the password and really kind of lessens that potential for you to cause some sort of production outage during that password rotation. So the other common thing I want to talk about, and we kind of already mentioned this with the cloud secrets, but with the cloud secrets engine, one of the most common use cases is, in a Terraform template, I have, a list of infrastructure I want to provision. So I can use that Terraform template to go out and request a secret from Vault, let's say for 10 minutes, to provision, infrastructure in AWS. Vault gives me that credential. The Terraform template uses that to log in, provision the infrastructure that it needs to provision, then it logs out, and then 10 minutes later, that credential is totally gone. So the database secrets engine, last on the list here, again, there are lots of different options, but these are the most common ones, is another very commonly used secrets engine. This secrets engine essentially operates basically in the same fashion in a lot of cases as the cloud secrets engine does, right? So you provide some sort of privileged credential to a database, you provide that to Vault, and Vault is the only thing using that privileged credential. And then when a user logs into Vault and asks for database credentials, once again, Vault is creating a completely random username and password, giving that back to the user. And then after, X number of uses or X amount of time, that lease essentially gets revoked by Vault. Vault logs back into the database, deletes those credentials, and that's it. So it's worth noting, though, that you can use that to store static database credentials if you want, and put some rotation mechanism around that as well. So any questions on any of that?
Yes, there's one question from Rohit. What kind of alerting and monitoring exists in Vault if Vault cannot revoke the leases?
So yeah, fantastic question. So I would start that first of all by saying that I've never run into a situation. I'm going to knock on wood there. I've never run into a situation where we couldn't revoke the leases. In a lot of cases, having a disaster recovery replica connected will help ensure that those leases are maintained. But for the most part, again, I would say the goal here is to get to a point where you really only need a credential for 10 or 15 minutes. And if that's the case, you have a very small window where something could go wrong and you're actually stuck with a bunch of leases, right? So the chances of it happening are not very great, but there are lots of mechanisms to make sure those leases are backed up and replicated and things like that, to make sure those things do get cleaned up after the fact. Anything you want to add to that, Brian? Or
yeah, I mean, if there happened to be some issue with Vault and it were to go down and there were leases out there, you couldn't revoke them. I mean, you can always still revoke them manually if you needed to, like on the back end platform. And then once Vault does come back up, you can still forcefully like remove them from Vault, right? If they were manually removed from the back end platform or something like that. If assuming Vault is up and running, it's super easy to invalidate credentials across, a huge array of credentials, right? So if you think, hey, somebody issued an AWS credential, right, but we're not sure which one it is, right? We want to invalidate every credential that was created against AWS. You can easily do that with Vault, so it'll wipe out every credential valid for AWS, and then you have your applications obviously re-authenticate and look at new ones, but yeah, it's pretty easy to revoke either individual leases or an entire path of leases.
Yeah, I think you briefly mentioned about different authentication methods to secure the Vault API from the Vault client. So what's the most common auth method?
Yeah, so from an auth method perspective, I think I can't remember how many there are. I think there's probably close to 20 different auth methods available. Generally, when I'm working with customers, what we'll do is there'll be one auth method that's more geared towards human access to Vault. So more than likely, that's, especially in a larger enterprise, it's going to be like an LDAP or an OIDC or something like that, right? We're going to want to use our backend IDP that we already have, right? It could be also Okta or something like that. But ultimately, we want to integrate with our existing IDP that we have. From an application standpoint, there are specific auth methods that are more geared towards machine-to-machine authentication versus human interaction, right? So you may have something like our app role, which is more geared for machine-to-machine authentication. Things like TLS tokens, those are more machine-oriented auth methods. And then you have, username and password and, other things like that are more geared towards humans. So generally what I was, when I'm working with customers is, we'll have one for human interaction and then one or multiple for applications, just depending on the use cases and what the applications may already support or what they will support in the future.
So the app role, can it be used along with mutual TLS as well?
With mutual TLS?
Yeah, with app role and mutual TLS as like second level of protection.
Yeah, so app role is really everything's based upon a role, and that role dictates like what access you have, within Vault. And so app role is really like a username and password for a machine. Every interaction with Vault is always going to be over TLS anyway. So all communication is going to be encrypted, but mutual TLS in Vault is going to be either with probably like the PKI secrets engine, which is again that automates the creation of certificates, and then replication between Vault's clusters also uses mutual TLS, but I don't know if you would necessarily use them together. It's usually one or another, auth method per application.
So mutual TLS, is it supported in the community version or the open source version?
I don't know if I don't know if it's MTLS. Let me just.
Yeah, I'm not sure.
Yeah, I'm not sure if it's MTLS or not, but TLS is supported in open source. Yeah.
So are there any like deployments where you front the Vault service with, let's say, Nginx or kind of proxy and run in the, let's say, in the Kubernetes deployment same pod, and then you enforce certain security mechanisms at the proxy level Nginx kind of deployments? Or you directly expose the Vault through the API?
Yeah, I mean, you can expose Vault to Kubernetes, right, as well if you want to. So there's a Kubernetes auth method that uses a Kubernetes service token for pods to authenticate to Vault in order for containers to go grab secrets and stuff like that to Vault as well. So if you're running on Kubernetes, it's probably the easiest way. But just to keep in mind that the configuration for a Kubernetes auth method, you're going to need one per Kubernetes cluster, right? So you can enable the Kubernetes auth method 100 different times if you want to under different path names. But that's probably your best way if you're integrating with Kubernetes, is to start using that. Now, they also have other methods of using like sidecar injection and things like that as well that you can do with Kubernetes.
Well, I think the question was more along the lines of can you front end it with something like Nginx or something? And so typically, people are putting some sort of load balancing technology or something like that. Is that what you were asking, Prabhat?
Yes, yes.
Yeah. So typically people are putting some sort of load balancing technology, not always Nginx, but lots of different options there. The cool thing is some of the new features that are starting to come into Vault are very much operational focused. And so, for instance, Vault has its own native rate limiting for requests per second and things like that now. Typically, things that you would need to put Nginx or a load balancer or something like that in front of Vault. Vault is starting to carry that natively, and so it is becoming much safer to just interact with Vault directly without needing that other technology on the front end. So,
sure, thanks. Yeah, I think we can move forward.
Cool. So this is the part where I would say Vault strays a little bit from the typical secrets management solution, wherein it provides the ability to process cryptographic workloads in different ways. And so we're going to talk about some of those real quick. Usually when Vault's not a part of the encryption process and the technical stack doesn't provide any sort of native encryption in transit or at rest or things like that, the developers or the operators are kind of left to manage that functionality on their own. And so what you see is this sometimes leads to opportunities for attackers in different scenarios to kind of siphon off some or all of that data as it's being passed around to different places in that stack. So through its own native cryptographic functionality, Vault can help secure some of that data in the absence of a native cryptographic offering. So for instance, suppose we have an application accessing and storing data in a database, and suppose that database does not have an option to store that data in an encrypted format. Or suppose that we want to take extra measures to ensure that data is encrypted. Even when a user has access to get directly into the database, that data is still stored encrypted. It's unusable for them, right? So Vault can be inserted into these processes between the application and the database in order to kind of encrypt and decrypt that data as it passes between mediums.
So how is that integration works? Is it the application has to talk to Vault and get the encrypted data and then write to the database? So the Vault will sit between the application and the database and do it automatically.
Yeah, so there's a couple different options there, and they're kind of outlined here. So the first one is the transit secrets engine. This is one of the oldest secrets engines and one of the most used. And so kind of how transit works is you go into Vault and you say, I want to create a key, right? And there's different properties you can kind of set with that key. You can make it non-exportable, you can make it non-readable, that sort of thing. And so essentially how that works is you provision this key, and then you're just sending base 64 encoded data into Vault, and Vault spitting back the encrypted form of the text, right? And so it's all passing through Vault. Vault's the only thing that's aware of the value of the encryption key and things like that, and it's handling all those cryptographic functions. So that's one of the most common ones. This secrets engine is actually used by one of the bigger stock exchanges in the U.S. Essentially, what they do is every Sunday night before the markets open, they'll spin up a whole new dynamic environment. They'll spin up new transit keys, and then throughout the week, as things are being traded, all of that's going through this transit secrets engine. All of it's being encrypted and decrypted 100% by Vault. And then on Friday afternoon, after the markets close, they tear down the whole environment, and then they start over again on the following Sunday. And so definitely a very trusted source for large financial transactions and trillions of them at a time. But that's kind of one of the bigger use cases, I would say, for that one.
The API is of HTTP, right? It's a remote API that you call from the application to the secret engine to encrypt.
Correct. And so it would be similar to an application, calling out to Vault to request let's say a secret to access a backend database. Instead, it would be the application would authenticate with Vault, and then it would send it base64 encoded data to a specific endpoint, and Vault would return the encrypted form of the text, and that could then be stored somewhere or something like that. And then, obviously in reverse, that would work to decrypt and access the data. So,
do you see any performance issue, like when you want to handle high volume of transactional data, you always need to talk to encrypt and decrypt. So what's your best practice like?
Yeah, so fantastic question. And so the answer to that is so there's a concept that we refer to as the Vault agent, and really what you're doing is you're taking the same Vault binary that you use, for command line access or to run, the Vault server or things like that. You're taking that same binary, you're running it as an agent on a host. That agent can basically hold a local key, and you can handle all the it allows you to basically handle all the cryptographic processing on that local host instead of sending it all to Vault. And so for scaling purposes, for large volume purposes, you would kind of shift to that model rather than sending everything to the Vault server.
So, then the encryption key would be with the agent, is it? Yeah.
Correct. Yeah. Well, sort of. There's some documentation I can share with the group on that, but it's kind of similar to the process Bryan explained as far as the master key and the encryption key. There's a local key that's used, but the key to decrypt that key is stored in Vault, right? And so you're accessing Vault to decrypt that local key, but at that point, all the cryptographic processes are being handled locally. So, cool. So the PKI secrets engine, we did touch a bit on this already, but generally what happens with this secrets engine is you configure Vault to be essentially an intermediate CA, and it can provision its own leaf certificates. And so applications that need certificates can make a call into Vault, can authenticate, can get a certificate. That certificate can be provisioned for, a week or a month or an hour or whatever you need. And then it will automatically expire, right? So you can build in some really cool automated rotation around this to rotate your SSL certs often and things like that. Really powerful feature for helping to secure communications. Probably one of the biggest users of this, and I apologize, I can't name customer names, but the largest cable, TV, and internet provider in the US uses the Vault PKI secrets engine to basically issue leaf certificates to set-top boxes, to cable modems, things like that. So pretty heavy usage there. There's another very famous coffee company that is using the PKI secrets engine to associate unique certificates to each user of their frequent buyer program. So just a couple of the different ways that the PKI secrets engine is being used in very, very, very large enterprises. So, and then the last arrival to the party, the last item on this list is one of the newer features that we've added to this. We call it the Transform Secrets Engine. This was basically, it was initially designed to use format preserving encryption. So you can basically take a pattern and match that pattern. And when you match that pattern, you're encrypting a specific piece in a blob of data. So the transit secret engine is essentially built to encrypt entire blobs of data, whereas the transform secret engine is built to encrypt just specific pieces of data inside that blob. The reason something like this is important is because so my time at Adobe, I worked for the digital marketing business unit, right? Adobe processes probably upwards of 75% of all digital marketing data that transacts across this globe. It's massive, right? Many trillions of transactions. Black Friday alone, we processed 6+ trillion transactions of digital marketing data. The reason a feature like this is important is because you have this blob of data, and this blob of data describes a person, right? It might say, this is Dan McTeer. He lives at this address. This is his phone number. He's 42 years old, and he really likes mountain biking, right? Where this comes in, where this becomes powerful, is they can basically use Transform to block out my name, my address, my phone number, but leave my age and my hobby unencrypted, right? And so when you're going through processing large volumes of data like that to find out how many 42-year-olds like mountain biking, you don't have to go through the process of decrypting all that data, but you can still block out those portions of PII to make sure the sensitive pieces are still protected. And so again, this the initial release of this uses format preserving encryption. The newer release will add traditional tokenization to that if you prefer to use tokenization. So yeah, really cool stuff. Anyway, yeah, I'll kind of pause right there for questions.
Yeah, so this is one question. Can a Vault support generating unique encryption key for each encryption?
It could do that, although I don't know that I would recommend doing that. Typically, the pattern that I see is people will provision an encryption key per application, or maybe even per function of that application, but they usually don't do one on demand. I would think that would be pretty heavy, and for the most part, the way that keys are generated and protected in Vault, there's really very little chance of that key ever being exposed. And so my argument would be, if there is no chance that anybody can see the value of it, then there's not really a reason to rotate it that often, right? So anyway, yeah, any thoughts on that, Bryan? Or
no, I think you hit it. Yeah, I think you definitely. I don't think you want to create a new encryption key for each unique item there.
Yeah. Cool. Any other questions?
That's all we have.
Yeah. Awesome. So thank you everybody for coming. We've kind of covered how Vault can proactively help you solve some of those big scary problems in security, through the use of good automation, through the use of dynamic secrets. This is kind of the power of Vault, right? The putting that ephemerality, that time limit around identity, around secrets, to make sure that nothing ever gets exposed as static, anything like that. For those interested, and I know we kind of put this as a focus topic, but for those interested, the book that Bryan and I created basically discusses the process of building out Vault as a shared service, and really kind of equips the reader with what they need to know to be successful in providing that as a shared service at a large organization. So thank you again for taking the time out of your day with us. And yeah, we'll answer any more questions that people have.
Yeah, thank you very much, Dan and Bryan. I think it was a very informative session and also a lengthy session. And thank you very much for taking all the questions. And thanks a lot, everyone, for joining in. And looking forward to meet you again in our next meetup. Thank you very much.
Perfect. Thank you.
All right. Thank you.